For number 7, we're asked to graph the equation y equals negative 4x squared plus 2x minus 3. Because the graph is in the form of y equals ax squared plus bx plus c, we know that the graph is a parabola. So that parabola is either going to open up or open down. Because a, the leading coefficient, is negative 4, we know that the parabola is going to open down. But we also want to find the vertex. The vertex is found by finding h and k, where h is equal to negative b over 2a, and k is the value of the function when you plug in h. So using the coefficients a, b, and c, a is negative 4, b is positive 2, we can plug that in to get the value for h, which is negative 2 over 2 times negative 4. We can simplify that to 1/4. So that's part of the vertex. The vertex is at 1/4. To get the other coordinate of the vertex, we need to plug in 1/4 for x. So that's going to be negative 4 times 1/4 squared plus 2 times 1/4 minus 3. Now when you simplify that, you can always use a calculator there. You get negative 11 over 4. So the graph that has that vertex located at 1/4 and negative 11/4 is graph D. Also notice, you can zoom in on that, you can see that the graph opens down. That negative 4 leading coefficient means that it's going to be a more narrow graph. Let's continue on to number 8. In number 8, if an object is propelled upward from a height of 48 feet with an initial velocity of 32 feet per second, then its height after t seconds is given by the equation h of t, which is equal to negative 16t squared plus 32t plus 48. After how many seconds does it hit the ground? To determine when an object hits the ground using this equation, this model equation, the object hits the ground whenever the height is equal to 0. So we're going to set the whole equation for height, which is negative 16t squared plus 32t plus 48. We're going to set that equal to 0. This is a quadratic equation. So one way to solve a quadratic equation is by using the quadratic formula. Other times you can factor if possible and set each factor equal to 0. So I'm going to use the method of using the quadratic formula where a is going to equal negative 16, b is equal to 32, and c is equal to 48. Using the quadratic formula to solve this, we know that the two values of t that would make this equation 0 will be in the form of negative b plus or minus the square root of b squared minus 4ac all over 2a. Now we get to simplify this or plug in our values to get negative 32 plus or minus the square root of 32 squared minus 4 times negative 16 times 48. If you're doing this on your calculator, please pay special attention to the order of operations, and you're going to divide the whole thing by 2 times negative 16. When you simplify that, t equals negative 32 plus or minus the square root of 4096, which is 64 all over negative 32. So the two answers you get are t equals negative 1 and t equals positive 3. Now t represents time, so it wouldn't make sense to say that the object hits the ground in negative 1 seconds. So the object actually hits the ground in 3 seconds. We can choose B as our answer. I've also gone through and looked at the graph using a graphing calculator. Pressing the y equals, you can enter the equation. Now if you just do a standard zoom, you're not going to be able to see all the detail of the graph. So I had to make adjustments so that I can see how high this object is traveling. So it starts off at 48 feet high, so we want to make sure that our y max is big enough so that we could see how high the object travels. So I have entered the equation into the y equals, and by pressing trace, I traced and found that at t equals 3, the y is equal to 0. That means the object's height is 0. That's when it hits the ground at 3 seconds.